webinar, Integrating the M1 with Z-Wave. In the next 60 minutes, you will learn what Z-Wave is, why you should be using it, how to set it up, and how to program it with the devices with our ELK RP software. I do want to remind all of you that this webinar is being recorded and will be posted on our YouTube channel. And if you haven't done so already, please go subscribe to our channel so you can have access to all of our webinars, how-tos, and product demonstrations. And during the webinar, if you have questions at any time, you can type in your questions in the question box of the GoToWebinar control panel. We will get to as many questions as we can, but any questions unanswered will be answered in our follow-up email on Monday, along with a link to the recorded webinar and other useful resources. Our panelists today include one of our very own, Amy Strickland. Amy has been working for ELK in our technical support department for almost 10 years. And some of you may have talked to her before when you call in into tech support for guidance. Our guest panelist today is Mark Walters. He's the chairman of Z-Wave Alliance. And as one of the founding members of Z-Wave Alliance, Mark has been working in home control and automation for over 20 years. So we look forward to seeing what Mark has to say during this webinar. And Z-Wave Alliance consists of over 250 companies that use Z-Wave in their products and services. And the Alliance supports the developer community, but is now shifting to include the support for installers and end users. So that's something to look forward to.
Thank you very much, Jessie. Want to just kind of give you an overview for those who maybe aren't as familiar with the M1 as, what is an M1. We refer to M1 as a cross-platform control. And what we mean by that is it's not just a security system or an energy management system. It is a system that can give you a lot of different features that you would typically maybe get from one system all in one system. So you're looking at security and fire. You can also have access control for those commercial type applications, and then of course some of the things that we're going to be talking about today are lighting control, HVAC, energy and task management, that sort of thing. So having all of that integrated into one system allows you to provide scheduled automation and control of virtually anything that you would want to control in a home or business, allowing you to control that on-site as well as remotely through smartphones, tablets, computers, that sort of thing, which is very popular today. You're seeing a lot of that type of thing where everybody has a smartphone and they want to be able to control their system from their smartphone. So that's something you can definitely do. The M1 is a very expandable system. It can fit a number of different sizes of jobs where you may have a small job or a larger job. And we also have wireless capability, so you're not only expanding out hardwired inputs and sensors and that sort of thing, but also wireless technology, including our two-way wireless. So that's a little bit about M1. Now I'm going to turn it over to Mark, and we'll learn some more about Z-Wave.
Great, thank you. I think we have a next slide up is a little bit about Z-Wave, but Z-Wave is a RF mesh networking technology, or a standardized protocol, that is used by over 200 companies to provide controllability of their products. There are over 900 certified products in the Z-Wave portfolio right now, and Z-Wave is unique in that we're the only technology out there that really provides product-to-product interoperability across manufacturers. And we had a slide a little bit earlier about Lutron Radio Raw, fantastic product, excellent, works great as long as you want to buy it from Lutron. If you want to buy outside of Lutron and have it be compatible with Radio Raw, you're out of luck. So with Z-Wave, what we have is we have the ability to mix and match from various manufacturers. This gives you the best choice and the best fit for your customer. You can pick the price point, you can pick the style, you can pick the color, and as long as it says Z-Wave certified on it, you'll know it'll work. And Z-Wave devices come in all sizes, shapes, flavors, price points, and control things like controllers, like light switches, lamp modules, appliance modules, locks, thermostats, window blinds, all kinds of sensors. Pretty much anything you need to do command and control in a residential or light commercial application. I think we have another slide. So why ziwei? Why are we even talking about this? As we were saying earlier in the presentation, the Elk M1 is a fantastic cross-platform control and allows you to do a number of things. In addition to just the core security type application. One of the things that we know today in the marketplace that's very, very hot is what we like to call lifestyle. And lifestyle is, all about making things happen remotely, making things happen from your smart device, your phone, your tablet, and it's all about giving consumers control of their lifestyle. We can be thankful for a number of large companies that have launched nationally in the last couple of years with lifestyle type solutions. I won't mention their names, but I think you've probably all heard the commercials on the phone or on the TV or on the radio for the, your daughter is locked out of the house and you're stuck in the meeting, so what do? Do you go home? No, you whip out your cell phone and you unlock the door. So what we have right now is we have a marketplace where this lifestyle, the benefits and capabilities of these lifestyle type products are being advertised to your customers and your potential customers. So why use ziwei? Probably because your customers are asking for it, and they're asking for it because they're hearing about it in national advertising, and we love that. The other reason to offer is it gives you the opportunity to expand your services, and expand your billable hours, so to speak. It provides you a little bit of additional stickiness with your customer, and it should provide you with a little increased recurring monthly revenue. You can charge a few extra bucks for a door lock, you can charge a few extra bucks for a thermostat, and your customers will pay that gladly, and they'll enjoy that service, and you'll enjoy the recurring revenue. So that's why we're talking about Z-Wave today and home control, and what we in the industry like to just kind of throw out there casually and call lifestyle services. Okay. So Z-Wave uses a mesh networking technology. What that basically means is that we have radio transceivers in all of the products. Some of the products are line powered and some products are battery powered. All of the products use a very low power radio frequency transmission to communicate with each other. Because it's low power, it doesn't go very far. So in order to get coverage for an entire house or an entire office building or something like that, we use a technique called mesh networking. And in a mesh network, every device, every Z-Wave device that is line powered, not the battery operated ones, but the guys that are plugged in, can actually act as a repeating station. So if your thermostat is trying to talk to the control panel and the control panel is at the other end of the house, it may actually make use of a receptacle or a plug-in module or a light switch that's always powered to act as a relay point for it. So RF mesh networks, what you need to know about them is low power. That means things can live on batteries for a long time, but you get to distance, the workable distance by using power devices as repeaters. An important point in doing Z-Wave or any mesh network is more is better. The more devices you put in, the stronger your mesh, the stronger your communication, and the fewer problems that you're likely to run into. Just make sure that you're including devices that are line powered, because battery operated devices do not act as repeaters. Okay. So beaming, a little bit of a difficult discussion, but it's the reality, so let's bring it up. Not all Z-Wave devices are equal. Z-Wave has been around since 2001, so it's quite an old technology, and what's happened over the years is that we've introduced many new features to the protocol. And as these features have come out, obviously the newer products can support the newer features and the older products don't support the newer features. So it's kind of a double-edged sword. In Z-Wave we have 100% backward compatibility. I have controllers and slaves that were built in 2001, and they still work with products that are being released today. That's a good thing. The more challenge to that is that oftentimes you can find networks that are mixed with products that have the newest, latest, and greatest advanced features and products that maybe don't support the latest and greatest advanced feature. The one that's going to affect you guys out there in the marketplace the most is this feature called beaming. Beaming is a technique that we use in Z-Wave for waking battery-operated devices up so we can talk to them. A door lock or a thermostat that's living on batteries wants to sleep most of the time. If it's up and listening all the time, then it'll run its batteries out shortly. So what these devices do is they do what we call beaming or FLIR's device, and they wake up, or actually they don't even wake all the way up, they wake partially up once every second, and they listen for a beam. If they hear a beam, then they wake fully up and they start to communicate. So these new devices, door locks and thermostats are mostly the ones that you're going to run into, need to have a device talking to them that can present this beam that wakes them completely up. So if you're designing Z-Wave networks and you're designing them with devices that require beaming, then the node that's directly communicating with it has to support beaming as well. And again, beaming is simply a newer portion of the Z-Wave protocol that lets us have devices that are battery operated, that can live on batteries for 3 to 5 years, but that can also be reached essentially immediately or virtually without any delay. In old Z-Wave and other mesh networking technologies, battery-operated devices wake up once every 20 minutes or something like that. It's not very good if you're trying to unlock your door lock if you have to wait 20 minutes for the thing to wake up before you can unlock it. So the old strategy of sleep, wake up once every 20 minutes and see if somebody's trying to talk to you doesn't work for a device like a thermostat or a door lock that you need to address immediately. So this is the beaming technique that we use. So I bring that up just to point out that as you build your Z-Wave networks, use the latest and greatest Z-Wave devices that support these newer techniques like beaming, and make sure that if you're using older devices, which are still very good, that at least in the case of the beaming, that you have enough beaming devices in your network to make it work. I think our next slide shows a little bit about how you can figure that out. Okay, so here's hopefully a very valuable tip for you guys out there that are designing Z-Wave. If you go to the Z-Wave Alliance website, www.zwavealliance.org, and click on our product section, or you can go to products.zwavealliance.org, you're going to get a product catalog, an online product catalog. And as you drill down through there and you click on more details, you'll see here I've got a data sheet that's Smart Code Deadbolt door lock. And it says right here with this little red oval, kind of hard to tell, but if you go to the website you'll see it. It says here you can download something called a Z-Wave Protocol Implementation Conformity Statement. Well, that's a big word, but Z-Wave Protocol Implementation Conformity Statement, or otherwise known as a pick sheet. You can download that pick sheet, and here's an example of the pick sheet on the right side of this slide. The pick sheet will tell you everything you need to know about the Z-Wave device, including down here it says supports Z-Wave beaming technology, yes. So when you're designing your network and you're figuring out what products you want to put in there, it's a good thing to go to the Z-Wave Alliance website, go to the product section, find the devices you want to use or the devices that you're using, and if you want to know what Z-Wave network features these devices support, you can download the pick statement and it will tell you here. So pretty much the only gotcha in Z-Wave is, again, if you're working with battery-operated devices that require beaming, make sure that you have other devices around them that support beaming as well. Okay? I'm going to hand the control of the presentation back over here in just a second, but just to kind of to summarize a little bit about Z-Wave, again, we give you the biggest ecosystem of interoperable products, and the way that this interfaces or works with the Elk M1 is through a serial adapter product from Leviton, and the serial adapter product from Leviton acts as a controller to the Z-Wave network, or what we would call a primary controller. And then it's pretty much standard Z-Wave. So Elk has done a wonderful job supporting a standard Z-Wave network as part of their control and cross-platform solution, and they do so through this serial adapter that's provided by Leviton. Okay, I think I'll turn that back over.
All right, thank you so much, Mark. Appreciate it. Okay, so as Mark was saying, Elk is able to control, talk to Z-Wave devices through a special interface that we've developed that works with a Leviton part. So we're going to dive into that just a little bit, but before we do, we want to go over just some of the basics that you would need to know for setting up a Z-Wave network. One of the main things that you want to do prior to actually getting into software, including devices in your network, that sort of thing, you want to go ahead and and make sure that everything is installed in the permanent intended location where you're going to have it. The reason that you want to do that is because you're setting up this network of devices, this mesh network, and it's important as you're going through that setup process that a device learns who its neighbors are, so it sets up basically like a routing table, so to speak, of how you can get communication from a device on the far end of the house from the controller. What are the nodes in between that allow it to get to that? So you definitely want to have these devices in place. Use a laptop with the Leviton installer tool, which we're going to talk about here in just a moment. So you're actually taking your laptop around the the home or the business to include the devices from where they're actually going to be once the installation is done. That's very important. So let's talk a little bit about how you would do that. Again, we're talking about running a laptop with the Leviton PC installer software and also using a Leviton USB ziwei stick as an installer tool. So you're going to need to be within about 1 to 2 feet of the device when you're including it. That's important. Again, you're going to be carrying your laptop around. That's the ideal situation here, is that you're moving to where the devices are instead of having them all set up close by and then going out and putting them in their permanent location. You will run into problems if you do it that way. You want to have them already there. But using the Leviton software, which you can get from their website, and of course this Leviton tool is how you're going to basically set up your network, including all of the devices that are part of the network. That includes the Leviton VRC0P, which is the serial interface that is required for the M1 to be able to communicate with Z-Wave devices. So that, as Mark mentioned earlier, is a controller, so that's going to be added into the system as a controller. Okay, so what you're seeing on the screen now, if you're looking at this screenshot here, is just basically the introductory screen that you come to when you launch the Leviton installer tool software. And they've actually done a very nice job here with their installation checklist. That's one of the easiest ways to set up Z-Wave, especially if you're new to it. It just kind of steps you through the entire process. So you can see here are the basic steps on the screen here. You're going to install the devices in their intended location, and then you're just going to step through this checklist, which is going to allow you to add your controllers. Again, that would be the VRCOP. There may be other controllers that are part of your network, but you definitely want to be sure that device is included. Then you're going to add your devices, which may be switches, dimmers, thermostats, locks, that sort of thing. Once all the devices are added, you need to update your controllers so that the controllers are aware of all of the devices that are part of the network. Then you can add areas, set associations, and then save and deploy the system. Now, after you've gone through those steps, there's a final step that you need to go through, which is an RS-232 setup step, and that allows the VRCOP, or the VRC0P device to have all of the information that the ELK needs to be able to communicate with it. But again, it's going to step you through that. If you need some help with this kind of thing, Leviton has a lot of great resources available to you on their website, and they have a forum community where you can get information as well. So between the documentation resources and that forum type community of other Z-Wave installers, you should be able to get the information that you need as far as setting up the Leviton part. One thing that's very important to note is that all of this needs to be done before the M1 is brought into the mix. So the entire Z-Wave network needs to be set up and functioning before we try to get the M1 to talk to it.
Amy?
Yes.
I have a couple of questions for you.
Okay.
The first one is the USB Z-Wave stick. Does the installer have to purchase that, or how do they get the Z-Wave stick?
That is a product that they will need to purchase. That is basically like a tool, so you don't necessarily have to have one of those for each installation, but each installer is going to need to have at least one of those to allow them to set up the different Z-Wave networks. So that is something that has to be purchased, but it is a tool, not a piece that will have to stay at that particular installation.
And then, do you know if the Leviton installer tool is Windows 8 compatible, or would...
Um, Unfortunately, I do not know the answer to that question. I'm sure that information is available on Leviton's website as to what the requirements for their software is. I believe it runs on Windows 7. I'm not sure about Windows 8. That's something we'll provide an answer to that. I'll research that and provide an answer in our follow-up.
Okay, and I have one more question, and then we can move on. Does the VRC0P1LW support polling to determine the on-off status of a light switch, for example?
Polling. I know that we get status of lights, like if you go to a load controlling device like a light switch and you change the state of it, the M1's going to know that. I'm a little cloudy on the reference to polling there.
It actually does. So polling is something that's supported by all Z-Wave devices, and it is supported by the M1.
Okay. Thank you, Mark.
All right, that's all I have. Thank you.
Okay, so now let's spend a little bit more time talking about the product from ELK that allows the M1 to work with the Z-Wave devices. So you'll see the part number there. It's another one of our fun part numbers. So it's M1XSLZW, and that is our interface for Z-Wave. That connects to our data bus. So this is going to connect into the keypad bus where you're going to have your keypads and your input expanders, all those devices, and it needs to follow the same rules for wiring as those other devices, as far as no more than 2 runs on the data bus and proper termination, that sort of thing. Nothing new there. If you are familiar with the M1, it's just another data bus device. It also connects to this device we've talked about a little bit, the VRC0P, and that 1LW is a denotation that makes sure that you're getting the right Leviton device. You want to make sure, as Mark was emphasizing earlier, that you're working with up-to-date equipment to make sure it's going to support everything that you want to work with. So you just want to make sure that you're getting the latest and greatest there when you're getting that interface. So this is something that we come out with, been over a year ago. We had a previous interface to Z-Wave that didn't allow us to do all the things that we wanted to do, so we came out with this new interface, and one of the big additions is the control of locks, which we've talked about a little bit here. Definitely something that is a benefit for us to be able to do that from the M1 as a security and automation system. And then of course this is also going to provide support for lighting and thermostats and appliance modules, that sort of thing. So this new interface has allowed us to support this newer generation of products. Okay, this is giving you just a basic general overview of the connections, which I kind of just described. You can see here we have our M1 system. This M1XSLZW is connected to the data bus, and then there is a serial cable that goes into the VRC0P. So that's the physical connections. And the VRC0P is what actually allows us to talk to the locks, the lights, the thermostats that are Z-Wave enabled. Now, we were talking about the mesh network earlier and how the more devices you have, the stronger your network's going to be. One thing to keep in mind is from this controller, your distance to a device that it is talking to directly can't really be more than about 30 feet. You've got a little bit of play there, but 30 feet is a good figure to go on there. And then of course when you're adding additional nodes, then you are strengthening that network. But just keep in mind that your devices that are not talking directly to the controller or with in the direct range of the controller, that's around 30 feet. And you're going to see the same thing between say we have the controller talking to a lighting device that is then talking to a thermostat. From that lighting device to the thermostat, you're looking at about the same distance there. So that's just a good figure to keep in mind when you're designing your system to make sure that you have the proper coverage on your network. And just going to quickly point out a few things about the layout of the board just to familiarize you with it. We've got here on the right side your green screw terminals for your power and data on the data bus, and then I've also pointed out where the terminating jumper is in case you need to terminate that device. We have our dip switch settings, which set the address of this device. Now it is a serial expander type device. We have the M1 XSP, which is used for other thermostats, lighting, uplink type radios, communications, a number of different things that serial interface could be used for, and we have some other serial interfaces. So all of the serial interfaces are considered type 5 devices, and so when you're addressing, you have to keep that in mind within that type. You don't want to duplicate any of your addresses. So the example shown on the screen here shows the address set to address 2. So just keep that in mind. You don't want to duplicate the address of this device with a serial expander should you have one, say, for cellular communication or whatever you may be using it for. And we have our DB9 connector, which is where the VRC0P is going to connect. There is a cable supplied with the VRC0P that you're going to use to make this connection. You should not try to make that cable any longer. The length that it comes is the specified length. You don't want to try to make it any longer. If you do, things are not going to work correctly, so just work with the cable that it comes with. Once you've made all these connections, then you can power up the system, and you need to be sure to do a bus module enrollment to pick up this device so that the M1 knows it's there. And there's an LED on this board. A slow blink on that LED gives you normal communications. When you first power up this device, it goes through kind of like an auto discovery mode where it's communicating with the VRC0P and getting all of the information about what is on this particular Z-Wave network. While that's happening, you're going to see a very rapid flicker of that LED, a very rapid blink. So you don't want to try to communicate with it or power down or back up or anything through that process. You just want to allow it to complete that auto discovery so that it knows what's on the Z-Wave network. Alright, now we're going to spend a little bit of time talking about the LCRP software, which hopefully some of you are familiar with. If you've attended one of our basic training webinars, we do give you an introduction to this software. We're going to dive in specifically to the things that you would need to do for Z-Wave. So we're going to start here with the lighting screen. So that's going to be found under the automation category here on the left side of the screen. You would go to lighting. And this is a manual setup process, so it's a good idea to have your Leviton software there as a reference for your node numbers. There's not, I've been asked this, I've gotten calls on this before, so I'm going to go ahead and address it. There's not an option at this time with Z-Wave for a quick import. Some of the other things that we work with you can import the data into, but with this you are going to need to manually transfer this data over into the lighting screen. The thing to keep in mind is that on the lighting screen you really only want to program lighting devices. So you may have controllers, you may have thermostats and locks that are part of the Z-Wave network that do not really need to be entered into this screen. So you can see here, if we look in the little screenshot of Leviton, we have an office lamp, which is a lighting device, as node number 3. We want to match that here, and you can put in the name. You need to be sure that the type is serial expander, because that is how the M1 is communicating, is through that serial device that we were talking about. And you can set the type as on, off, or dimmer. Now you'll notice with these other ones we've given them the name NA. We've left the format standard. We've not chosen to show those, so that's how you would want to work with your controllers and your thermostats on this screen. Just you don't have to name them. You don't want to set the format to serial expander. So how, if you have thermostats, they're not being added to the lighting screen, how do you address those? It's pretty straightforward. If you look here on the screen, we have a first floor thermostat, which is our node number 4. The lowest node number, and working up from that, if you have multiple thermostats, is going to be thermostat 1, and then 2, 3, 4 sequentially on through the 16 possible thermostats that the M1 can support. So our lowest node thermostat here is node number 4, which is going to map to thermostat number 1 in the ELK software. So that's, sometimes a point of confusion. You want to look at this and say, okay, it's number 4. I should set it up as number 4 in the ELK. Again, you want to just keep in mind it's the lowest node ID is going to be your first thermostat, and then working from lowest going up from there to populate the 16 possible thermostats.
Amy, before you move on, back to the lights. I had a question. Can you mix Z-Wave lights with other formats such as an X10?
I strongly discourage doing that. We do not recommend doing that at all. There's a lot of potential issues that can happen with mixing technologies, and Z-Wave is going to give you your lighting, thermostat, and lock capability. So if you're going to work with Z-Wave, we recommend that all of your lighting be Z-Wave, that you don't try to mix something in like X10 or one of the other lighting products that you could use the M1 with. But so we really do not recommend doing that. If you have any overlap of addressing, you're going to run into problems. You also, if you have a Z-Wave thermostat, you can't have hardwired thermostats on the same system because they won't work. So short answer, no, don't mix technologies. It's a little late for a short answer, but there it is.
Thank you, Amy.
Thanks.
Oh, wait. Amy,
Okay.
I do have one question. How are thermostats added to the Z-Wave network?
That's going to be done through the Leviton software. So when you're using that Leviton tool and the Leviton software, those will be added or included into the Z-Wave network under the Add Devices section. So you'll add those. That's where you're going to add your lighting devices, your locks, and your thermostats. And so with each thermostat, it's a little bit different as to what you have to do with the thermostat. You're just going to want to reference the documentation, but typically there is a menu that you go into in the thermostat to allow it to be included into a Z-Wave network. And once it's in that include mode at the thermostat, then you'll be able to add it in the software. But just reference documentation, because how you get there is going to vary based on the device that you're working with.
Thank you, Amy.
You're welcome.
Just a quick add to that. I know it's often really attractive to try to work with multiple technologies, or oftentimes with a customer that maybe already has some products in his house, like X10 or something. But with the mesh network, the more devices you have, the stronger the communication because of the nature of the mesh. So when I'm talking to a customer and they're saying, hey, I just want to put in a couple of ziwei devices and I want to use the rest of my existing X10 or something like this, I'll sit down with them and explain that what they really want to do is move to the latest and greatest and best technology, and they really need to do that across all the devices in the house because they all support each other in a mesh configuration. So sometimes that's a good argument to get everything updated at one time.
That's a very good point. Thank you, Mark. Okay, next we're going to talk about locks, and this is where things can get a little bit more complicated as far as the setup. Once you know what you need to do, it's fairly straightforward, but it's because you are setting up these text strings, it can be a little intimidating at first, so maybe we'll take a little bit of the intimidation out of that for you here today. With the locks, that we can support up to 10 locks, and you need to set up text strings for each lock. And so you can see here on the screen I have the example for lock 1. So you have a lock command and an unlock command. Now one thing that does catch people is the unlock command. When you're setting up that text string, as you can see on the screen there, it's ulock instead of unlock. It's the unlock command, but the N is not in the text string, so that catches people sometimes. That's one of the little gotchas there. So you're going to set up these. If you had multiple locks, you would set up similar strings. Again, just changing the number, lock 1 or ulock 1 for your lock and unlock, and then changing that to 2, 3, and so on up to 10 possible locks. Once you create these strings, then we'll be able to do things with them in rules, send them out when we want to issue that command, and also these are going to be the commands that we'll see if someone were to manually unlock the lock, then we would actually get this string back, and we can trigger some things on that. So we'll go over some examples of that. But just want to show you here on the screen, this is how they need to be set up. And I mean, this includes that the little less than sign, and then your $M, which is basically a carriage return. All of that needs to be there. And so here is a table that's just going to give you an overview of those lock commands. And you'll see there's also some additional options here. We have a command here to get status of a lock. There's a command here to activate the discovery mode, so you could do that through a string. Again, you can also do that just by powering down and back up the M1 XS LZW. And then we also have some information about the status of the battery. So these strings are things that you can set up to get that information and also to control these. And another thing I want to point out here is that if you leave the number off, if you have your lock or your U-lock without a number, that's going to control all of the Z-Wave locks. So that's kind of like your global all lock or all unlock on your locks. And if you want to control a specific one, you specify it by number. So the next thing that we're going to get into is rules, and before I go into that, I would just want to check with Jessie and see if there are any questions.
I do have a couple of questions.
Okay.
One is, are all the major brands of Z-Wave motorized lock sets equally compatible with ELK control?
We work with the locks from Yale, Kwikset, and Schlage. Other Z-Wave locks I don't really have any experience with. I would imagine, because Z-Wave is kind of a language here, that we would be able to support those. But as far as confirmation of that, I wouldn't have that. But I know that we are compatible with locks from Yale, Kwikset, and Schlage. So those would be
So from a Z-Wave standpoint, they absolutely are. A Yale lock looks like a Kwikset lock, looks like a Baldwin lock, looks like a Schlage lock. That's the beauty of Z-Wave interoperability. If it's a certified lock, like any other certified lock, at least for what we call basic functions, lock, unlock, status, battery, things like that. Now, some of these locks have advanced features that may not be fully supported, but as far as the ELK panel knows and the Leviton serial adapter knows, it's a Z-Wave lock, and that's really all it does need to know, because they all work the same.
Thank you. Oh, sorry. Another question I have is, what is the practical maximum number of devices on Z-Wave network?
So that's a great question. Yeah, I'm sorry. Do you want to take that, Amy? You probably have an answer that you guys have at ELK that you prefer.
I would say that we probably need to address this question in two parts. So I'll address the ELK part of it, and then I imagine it's just as far as Z-Wave is concerned, the answer is going to be much different. But from the ELK system, from what we can support on a Z-Wave network, is up to 128 lighting devices, up to 16 thermostats, and up to 10 locks. Now, as far as what the Z-Wave network itself, what limitations, if there are any, I'll allow Mark to address that.
Okay, well, I think that just about covers it. So in the Z-Wave world, the maximum number of devices in a single network is 231. But if you try to put 231 devices in a single network and manage that, I think you're going to pull your hair out. I mean, so we typically suggest that typical networks are 70 to 80 devices in a really big house, and that works just great. If you're going to go beyond that, sometimes it makes sense to break the system down into 2 or 3 different networks and have each controller, maybe a controller for the top floor and a controller for the main floor or something like that. But the numbers that Amy just provided are comfortably will work comfortably within the Z-Wave technology.
Thank you, guys. That's all I have.
And before we move on, I want to go ahead and bring up one thing that I get asked a lot. I'm surprised that it hasn't come up yet, and maybe it would have anyway, but I'm just going to go ahead and put this out there. I get questions about the locks and the codes that are stored in the locks. We can't manipulate those codes. We don't get that information transmitted to us as far as what code was used for the M1 to be able to log that or do anything with that information. The M1 can't change the codes in the lock or view them in any way. So we're basically talking directly to the lock to issue commands to it or to get its current status, but we're really not involved in the codes that are stored within that lock. And with that, I'm going to go ahead and move into some rules examples here. So we're just going to start out here with a basic example, making some changes when the system is armed. So our whenever is when the system is armed to away mode. Then we want to turn off this particular light. We will make some changes to the thermostat set points. Now you'll notice that in that particular rule we're not issuing a command to the lock. You would think, okay, you armed the system, you want to go ahead and lock the door, but you do need to wait until to give a person time to get out. So instead of adding that to our armed rule, what you see here on this second rule is showing that lock command is being issued when the exit delay expires. So we've armed the system, we've given the user time to open that door, get out, and then once that exit delay expires and the system is in its fully armed state, the door will automatically lock. Now one thing that I will point out here with the lock commands, you'll notice here that we have in the then statement it says then send the following text, and this is where those text strings that we set up come into play. So we're sending out a command to lock number 1. We're sending that through port 2. Now in this example, as I was showing you on the picture earlier where I was pointing out the different parts of that interface, I showed you where you could set the address and that it was a serial expander device and how you needed to make sure not to duplicate addresses. Well, that address is directly tied to the port that we specify this string be sent through. So if that M1 XS LZW had been set to address 1, then this would need to say through port 1 instead. So that's very important. You do need to specify that port, and it needs to match the address of your interface. Alright, here's a similar example, but now we're doing some things when the system is disarmed. We're turning a light on. You can see this is a dimmable light, and we're setting that brightness to 40% instead of just turning it on to 100%. We are using some of that dimming there, which is great for creating the right atmosphere and also for energy savings. So that's just something to keep in mind. Take advantage of those dimming capabilities. We're also making some changes to the thermostats, and of course if we had multiple thermostats we could continue adding then statements to make changes to those thermostats. Now in these examples I'm showing changing set points. That's one thing that we can do. We can also change modes on the thermostat. If it's a type of thermostat that has auto heat cool, that kind of thing, we can support that, issuing those commands, and fan control and hold control are the basic things that we can do with the thermostat. Now this kind of ties back into that first example that I was showing you with that you can sort of still see there faded out on the screen. We sent a lock command when the exit delay expired. In some cases you may not want to wait for that exit delay to expire, but you do still need to also account for, if you just walked up to the keypad and armed the system, that's not the time to lock the door that you're wanting to go out of. So that's where you have that exit delay ends option in there, but something else that you can do is actually look at the state of that zone. So we can say whenever that zone goes into a secure state and the system is armed, this is a scenario that would really only happen right after arming. Then we can also go ahead and send that lock command at that time. So this is the scenario that you've armed the system, you've opened the door, which created the door to be in a not secure or violated state, and then when that door is closed again it's now secure. The system is armed because you just armed it, so we can lock the door, and that would make that go ahead and happen as soon as you close the door after you left. Okay, in this example we're showing how you can use those text strings coming in to the M1 to provide, say like a status indicator. So what we've done here is we have output 4. Output 4 is an output on the M1 system that does not physically exist. So we're using that output as a phantom output, so to speak, here. And we're just saying, when we receive this string indicating that the lock number 1 is locked, then we want to turn this output on. And if we receive the string indicating that lock number 1 has been unlocked, then we want to turn the output off. And that's going to give us just a visual indication. Since we are manipulating the locks through text strings, if you want to have something on your user interface to show you is the lock currently locked or unlocked, say from your smartphone, this output 4 in this case is going to provide that status indication for you. And then you can also, if you wanted to have that remote capability of locking and unlocking, you can certainly set up tasks to do that, and I'd be happy to dive into the RP software and show us that if we want to get into that example. Before I do that, because we are getting a little bit closer to the end of our time, I want to make sure that we have enough time to address your questions, so I'm going to check with Jesse and see if we have any questions that we can address, and if we have some extra time, I'll show in RP how to set up a task that can be activated from the smartphone.
I do have a couple of questions about lighting. Do light scenes activate at the same time?
So to try to address this, I imagine that we're looking at having a rule that has multiple then statements to control lights, and those are going to happen. Those commands get sent out in the order that they appear in the rule, but it's all happening very fast, so it's not, you shouldn't really see that popcorn effect so much of that it would appear that there's a delay between them or anything, because it is fairly quick communication speed there. But as far as scenes and groups and that sort of thing, that's something that you can set up and can be controlled from the M1. Unless it's something that's been recently added, I don't think the Leviton software supports setting up the groups, but there is a way to do that through just sending the appropriate strings to the VRC0P through like a hyperterminal session or something like that. And we talk about that a little bit in our documentation. I'm not sure whether I've answered the question or not, and I don't know whether Mark has anything to add. But, again,
yeah, not a lot to add. You mentioned popcorn, which is kind of the dread of any lighting actuation scene or group. If your Z-Wave network is set up properly, everything was put in its place and then enrolled and then not moved. You should not see delays in actuating Z-Wave lighting of more than a few hundred milliseconds, and that's going to be just perfectly fine. If you're going to do it all off for an entire house where you may have 60 or 70 lights, now that may take a second or two, but again, customers will sometimes complain about that, and you can let them know that they've got a couple choices. They can have everything hardwired and spend literally tens of thousands of dollars, or they can go with RF and they can they can wait a second. So oftentimes a consumer will understand that very quickly when they figure out what the trade-off is between using a radio frequency communication, any of them, not just Z-Wave, and hardwiring, which is very invasive and very expensive.
Another question I have is it easy to add a new Z-Wave device to an existing Z-Wave system?
Yes, it is relatively easy to do that. Again, you're using the Leviton software and tool. You'll be able to include new devices into the network. That's software does allow you to save your different setups. So as you're working on different projects, you'll have those saved, and you'll be able to pull that project back up and add to it. Not very hard at all to do that. One thing that you do need to keep in mind when you make any kind of changes or additions, or maybe you've removed some devices for whatever reason, any type of changes that are made to the Z-Wave network, to make sure that the M1 is aware of those changes, you do need to go back through that that checklist of making sure that the controllers updated, that you've gone through that RS-232 setup step so that the controller has all of that information in the format that the M1 needs. And then after that's been done, then you need to make sure that the system is power cycled so that we're powering down and back up the M1 XSLZW and allowing it to go back through that discovery mode. So once you make the changes or additions, you just need to make sure that that all gets trickled down to everything else by going through that checklist each time.
I do have another question. This is targeted for Mark, but I also think Amy can help on this. This is from Chris, and he said, I'm often called on to install Z-Wave locks in larger homes and integrate it with ELK. If we're just using Z-Wave for locks, not lighting or devices, what line-powered repeater would I rely on to build Z-Wave network?
That's a great question. So what we typically use in a situation like that is any plug-in appliance module, simply because they're very easy to very easy to install and very inexpensive. One of the challenges, though, is if you plug in a appliance module or a plug module, sometimes customers unplug them or they move them around, and that can get to be a bit of a headache. If you go to the Z-Wave Alliance website, go to the product section, and you go to the U.S. products and then click on the various product categories, you'll see that there's a number of different products that you can use. I like using hardwired receptacles because consumers don't move them around, and you can actually provide an additional benefit by switching a floor lamp or something on and off like that. There are a couple of companies that have just released repeaters. These are that's all they do is repeat. They don't have a switching function of any kind at all, and they're actually configured so that you can screw them down to the wall plate so they don't get removed. So anyway, any Z-Wave product that's line powered will work for you. If you're working with door locks, make sure it's a newer one that supports that beaming feature. You can find all those products and all that information on the Z-Wave Alliance website.
Thank you, Mark. Another question I have is, can I use UPB for lighting and Z-Wave for locks and thermostats?
Technically, you could. Again, it kind of goes back to Mark's point earlier about the mesh network and how you're going to have a stronger network if you go ahead and incorporate the lighting devices in as well. And when you're talking about this beaming, if you don't have any lighting devices, then you don't have really any devices that support the beaming to be a node in between the controller and the lock. So you really kind of tighten up your ability there as far as your range if you don't have the lighting. So while it would be possible to do that, it's not something I would recommend.
Yeah, and Amy has a great point there that if you do that, or even if you're just designing an all Z-Wave network, we do need to make sure that we have line-powered devices between the controller and the door lock and the thermostat, and that the device that's closest to the door lock or the thermostat, or the device that's closest to the beaming device, also supports beaming. The ones in the middle don't have to. They don't care. But the guy that is actually going to be the last relay point before the door lock or the thermostat needs to support that beaming command so it can wake it up. Almost all of the newer devices do. Anything built in the last year certainly does, but you can tell for sure by going to the Alliance website product section and downloading that PIC conformity statement.
Thank you. And another question is, are there any typical significant sources of radio interference for Z-Wave in home use?
That's a great question. Because we operate in the unlicensed band, there is a potential for other devices to interfere with Z-Wave or any RF technology that's in the unlicensed band. We are in the United States. We're using 908 megahertz. There have been reports of some battery monitor or baby monitors, not ones with video. The ones with video are all 2.4 gigahertz, but baby monitors that are audio only, some of those actually are very close to the Z-Wave frequency and can cause interference. And you'll note this by just getting very intermittent performance and really crappy range. So if you're getting intermittent performance and crappy range, look around for a baby monitor. That's an audio-only baby monitor. You can't change the operating frequency for Z-Wave, but all of these baby monitors do have multiple channels of operation. So if you do run into that problem out in the field, go to the baby monitor, change it from channel A to B or whatever it is. Change it off of whatever channel it's on to a new one, and that will take care of the problem for you.
Great. And Kevin actually just asked a really good question. If there are 3 companies involved, you have Elk, the device, and Leviton, who do we call for help when there's problems?
That's going to depend on where the problem exists, and of course you can always contact Elk Tech Support and we will help you try to identify where the problem is, and if it's something that we can help you with, we'll proceed in doing that, or if it's something that is outside of our realm of support or control, then we would direct you to the appropriate company to address that. So just to dive into that just a little bit deeper, if you're having problems, say for instance getting the Leviton software to recognize a particular device, that all of that is happening before the Elk system is even really being brought into the mix. We don't really have any control over which devices are being recognized in the Leviton software. So again, feel free to call us and we'll talk with you about it, but that is going to have to be something that we would revert you back to Leviton for. Now, if your problem is, everything's set up in the Leviton software, everything seems to be working, but the Elk won't, turn on this light or change this thermostat or control the lock, that's definitely where we would dive in and really start helping you troubleshoot that problem. But by all means, if you're having trouble, give us a call and we can at least get you pointed in the right direction if we're not the right people to help you.
That's a great question, Amy, and I'll just throw in really quickly that when you have many companies involved in the solution, sometimes it is tough to know where to go. Amy's answer is right on. If it's a Z-Wave problem, you probably want to start with Leviton since they're the primary controller. Please know that you can always contact me at the Z-Wave Alliance. It's just mark@zwavealliance.org. And we'll do the same thing. We'll try to help you get that answer, whether it's something we can answer or whether we find somebody out there to help you with that. We'll certainly do that.